Hi and welcome to Patch Day 34. Today I'm going to make a granular synthesizer thingy. There's a lot of interest, I guess people are interested in how to make granular samplers. I call them samplers, but they're granular synthesizers by definition, I suppose. There's the one down here in the Max examples, which exists down in examples, max 5 examples, sampling granularized dot max pat. And as many of you have probably already played with this and found out, there's a couple of levels of abstraction going on here. You have this nice looking interface that does everything you might want it to, maybe. And then contained within this B patcher is something that's hidden away down here, which is I think called R grano, and then hidden behind in here somewhere, if we hit the presentation mode thing, is where is it? Oh, you can't see it, it's too low. It's R grain dot max pat, and then there's grain. And anyway, if you can find your way through to the guts of this thing and figure it out, then good on you. There's quite a lot of people who probably feel like that's a bit too much to deal with. So we're going to look at just making our own granular playback engine thing. First thing we're going to do is want to use a file to be using in this granular playback, and I'm going to use the drop region. So double click and bring up the palette where there's a drop file. I guess it's called drop file. All right, and that's going to then go through a prepend object. So a new object, prepend, replace. So it will replace a buffer with whatever file we drop in there. And I'll make a new object called buffer, and I'll give it the name Amen. I don't know if that's a good name. It's not, sure, who cares? So we'll put the replace to that, and we'll want to see the file through some kind of waveform, which is just like on the Max example. So we'll use a waveform. I can never find those on the I can never find anything on the palette actually. So waveform is a good name for this thing, waveform tilde, and it brings up the waveform object like so. All right, and you want to set the name of the buffer through a message coming into this thing. So set amen, and as soon as you hit amen, it should load whatever's in the buffer. There's nothing in there yet. It should set that, so we can actually, so that when the file has been loaded, we can automatically set the buffer thingy. Oh, yeah, I'll put this all the way down here. All right, so next thing is to load in a sound, I guess. I'm going to go with the same one that's in the example in the Max examples. Max 5 examples, sounds. They use the Anton one. Drop that on there and you can see it appears in the waveform. That's all really good. To do the windowing, I'm going to use the same Gauss window that I had on Patcher Day 32, which was the the grainlet percussion thing. So I'm actually just going to paste this in here, which comes from the grainlet percussion. If you don't already have that built, then you can probably just follow along. I'll just look at this and pause it when you need to. So I'm going to create a buffer that's 11.6099 milliseconds. Somewhere in the discussions on the forum, someone was suggesting that works better. If you want to figure out what length this buffer should be, you can divide 512 samples, which is the length of a, let's get out our calculator here. I can divide 512 samples by 44.1, and I get 11.609. So that's where that number came from. All right, and inside this patcher here, this sub patcher, I have this all built. You can just copy this. So again, you probably want to pause the video right here if you want to get in on this thing. It's this expression that could take you some time to figure out. As in Harmonic pointed out last time when I did Patch a Day 32, I actually zoomed in and managed to miss some of this. The part of it was chopped off. Hopefully part of it's not chopped off right here, and you can pause the video if you need to. And another thing is that, as according to Code Noise, this comes from Nathan Volek's his GTR.winmaker. So he has GTK. Code Noise says GTR, but GTK, which is the Granular Toolkit by Nathan Volek. If you've got this built like this, you're probably going to want to hit the load bang button to make it actually. Oh, okay, let's click that message for the scale first, then the load bang, and then if we double click the window, the buffer win, we should see this nice looking Gauss window. All right, that's that. This is the window we're going to use to window the samples. We're not going to use a triangular window that you would get through a line by default. Now the next thing I'm going to do is a whole bunch of I tables that are going to be the tables that are used for the parameters of the granular synthesis. So if I make a new object, I table, again I could make this from the palette, but I'm just going to make I table, that's table with an I before it, and I'm going to type in at name, and I'll call this IGT for intergrain time. If you are wondering why I'm giving the attribute, which is the at name argument, and the IGT, it's because Max doesn't like to name I tables unless there's a table already that has that name. So if I don't have tables built already, I'm going to have to name it using the attribute when I create the iTable object. I know that seems convoluted, but it's all good. Hey, it's getting that from somewhere else. That should have come up like that. All right. If you get the info, if you bring up the inspector, so Command I, the inspector will show you that its name is IGT. We're also going to want to change its scripting name. We can give it the same name. The reason why we're giving it a scripting name is because we're going to use auto patter and patter storage later on in this patch a day, so we can give it the scripting name IGT. We're going to do this for a whole bunch of tables, so this is going to get a little tedious. So we make a new object again, N for new object, I table with the attribute name, and the name is, this one is going to be DUR for duration. All right, name duration, and again it's got its, yours will come up like that. Mine came up because I had that name used somewhere else. Okay, again the scripting name, want to save it, give it the same scripting name as the table name, or a different name, doesn't really matter. Scripting name, like I said, because we're going to use the patter storage. Right, so another new object, I table with name at name. We'll call this one amp for amplitude. All right, and again, this is going to seem very repetitive. I'm going into the scripting name and I'm giving it the same scripting name as the table name. All right, and again. All right, so another new object, I table with a name at name pit for pitch. All right, and I can again go in and bring up the inspector, Command I, give it a scripting name, PIT. So table names and scripting names are the same. I guess I could label these if I was going to be smart, so I can make C for comment. The first name was time, intergrain time, I guess, to be more precise, intergrain time. And I could give this next one a comment. This one was going to be duration. Duration, yes. And this one down here was going to be, I've forgotten, amplitude. And this one next door, comment here for this one is going to be pitch. All right. So that looks great. All right, so now we can, the last thing we're going to want to do is to put an I table over this here waveform, so we can set different points in the waveform, set different positions for the playback of the grains. All right, this should have come up like this, by the way. All right, so I'm going to make a new I table again. Table. I table with the at name. Hello, at name. We'll call this pos for position. And this already has stuff stored in it, which it won't for you. And if I bring up the inspector, Command I, then the table name and the scripting name can also be pos. Okay, the other things I'm going to change on this, because if we just look at this the way it's going to look, if I just put this on top of the waveform, which is where I'm going to want to put it, well, we can't see the waveform anymore. So Command I again for the inspector, and the background color, we want to set the alpha of that to, we want to set the alpha down to 0 so it's completely transparent. All right. And then next thing we want to do, again, if we look over here, we draw something in this table, we can hardly see it because it's black. So we'll get info on that again and make the table points color. Let's make that a beautiful shade of red. Okay. That way we can actually see what we draw in there. Okay, so that's enough for that sort of stuff. We'll need to stretch this out. Oh yeah, the other thing I wanted to do is to set the table size to 256, which happened by default because I had it somewhere else, but now I'm going to change it to 256. Okay, that should be enough right there. 256, just to give it a little higher resolution on the time axis. We could make it even greater. You know, you could make that table size huge. All right, and the other thing I suppose that's worth pointing out, or would have been worth pointing out before I even started making this, is that we're going to use these as probability tables, so that the y will be the probability and the x will be the value that we're going to get out of it. Right, so the first thing, I just need to make one other little improvement to this patch. We're going to make a new object n with a send on, off, so that we can turn on and off our granular playback with a toggle. So T on the keyboard to make it toggle, and that can sit right there, beautiful. All right, I think that's enough. Now we need to make a new, let's save this just so we don't, so that, you know, heaven forbid Max should ever crash. I'll make a new folder. Sure, I'll just save it here. I'll call this my granular. Okay. We're going to use make a new patcher now to load into a poly tilde. We haven't made the poly tilde, but we can make that once we've made the patcher. And our poly tilde patcher is going to have no inlets. It's just going to have an out. So we're going to have a new out tilde with 2 we're going to use this in stereo. I mean out 1 and out 2. Hello. So out 1 and out 2 for the left and right sides of the playback, which we might as well make first, I guess. Doesn't matter what order we make any of this stuff. So we'll make a new object, play tilde, and we've got amen and 2 for being stereo. So between the amen playback and the outputs, the outlets, we're going to want to put a multiplier on each channel. This is for the windowing, so we can put the multiply our amplitude of our sound file playback through these multipliers, and then we have to figure out where this window is going to go. So we've can start, I suppose, recreating. Hey, I managed to move that. Oh. All right, so we can start creating the tables in here that we're going to use. We can remember there's one called table was called pause. There's one new table. There's one called amp. There's another one. I can just start option dragging those to make copy them. There's one called pit for pitch. There's one for IGT, which is the intergrain time. There's one for duration, which we use DUR, and position and F5. If we look over here, we have 5 I tables on that patcher. So good. Now we're ready to, and the other thing again, remember we had a new an object here. We'll need this on off to turn it on and off. The first thing that I'm probably going to want to do, or one thing I'm going to want to do, is that when I turn this thing on and off, we're going to select SEL1, so that when we turn it on, one thing we're going to want is to get the duration, the length of whatever we've loaded into the amen buffer. So we're going to use an info tilde with the name amen, so that when we turn it on, we get this total time in milliseconds coming out here. And since this position table here has 256 points, I'm going to make a new object that divides the total time by 256. Not sure that floating point is really necessary here, but hey, it doesn't hurt. So there we can put this in here, and then every time when we multiply the table position by this, we should be getting the position in the table, the position in the file. So I can do that already. Divide by, again, floating point, does it matter? Table position divided by, not divided by, but multiplied by, sorry. So yeah, table position multiplied by this buffer length divided by 256 should be the point in the position in the table that we're interested in. I'm going to shift all this up, so we're going to run out of space here. All right, what's next? So I guess the first thing we're going to want to do is well, let's go back to this windowing business here. The one thing that we probably can be aware of is that this table here called amp is going to be 0 to 127. We're going to probably want to divide that to somewhere between 0 to 1, or I'm actually going to do it by divide it by 256, because there's all sorts of when you get multiple grains going, it's going to be pretty loud. So we'll divide whatever the amplitudes are by 256, and we'll multiply it. Well, let's get this cycle going here. New object, cycle tilde with the win, which is what we've loaded into it. You can see that nice looking Gauss window there again. And we're going to multiply this cycle output by this here. So let's just do that. All right, move them around, shift everything around. All right, so just multiply with a tilde because it is a signal. This amplitude by the window amplitude and multiply that on the output of the playback, and that should be pretty golden. Next thing we need to figure out is how to drive this the phase of this window. So let's use a line tilde for that. New line tilde, and stick that in there. And what else do we need to know about this? This here. How can I make this thing neat? I don't know. Right. Yeah, we're going to get this will be the phase of 0 to 1. So we're going to make a message here to make this line tilde start at 0, comma, go to 1, and we're going to have this replaceable argument. This replaceable argument, $1, is going to be the duration of the grain. Alright, so we can stick that in there, and we actually just said what we needed to know about this duration. I mean about that, setting that value. We're going to get that from the table duration. The next part of this is just a little bit tricky. We're going to want to hook up this playback the time in milliseconds to this, so it's synchronized with the window that we're reading, that we're using to multiply its amplitude. We're going to want to multiply this 0 to 1 value by the duration, so we can use a multiplier here, multiply tilde. That's going to be the duration, and we're going to want to also add something, which is the position. So we'll make a new plus tilde for the position. Obviously, if we did this the other way around, plus and then multiply, it wouldn't be right at all. That's kind of common, isn't it? Yes. All right, so this is our position here that we figured out already. We can just bang that straight in there. Again, keeping this patch neat is going to be a bit of a challenge. And then the thing about multiplying this to get the duration is not as simple as it might seem at first, because we also need to take in to account the pitch. Okay, and how do we do that? Well, I'll show you. I mean, the simple way is to figure out somewhere that's already done this, which is in the example that we were talking about at the start of this patch a day, which is in, again, the Max 5 examples, sampling granular. And if we have a look at this R grain, we'll be able to see over here where they're doing very much the same thing. The transposition ratio, double click this little subpatcher here. The trans ratio has transposition in, which is 12 equals up an octave, minus 12 equals Scooby Snacks, and that's all really good. That's exactly what we want in these numbers here. 2 for up an octave and 0.5 for down an octave. So I'm just going to steal this, select that, and copy it, and I can close that now and just paste this in here. So this is going to work for our pitch. All right. And this is midipitch it's going to be using. You could change this so that it wasn't quite so large, the deviation in pitch. But anyway, so there's an outlet here that's kind of hidden with the big borders on that trans ratio action. And we're going to multiply the duration by this transposition ratio, which should give us the kind of pitch we're after. Again, I'll use floating point just to be really pedantic, but there we go about multiplying this table duration by the pitch and sticking that in to that multiplier right there. Okay, this is sort of getting there. This IGT value, I'm going to run that from a delay, so new object del for delay, and I'm going to stick that in there. And this is where all of these tables are going to get banged from, including the table that sets the intergrain time. So I have this weird suspicion that if we set this to 0, it's going to cause problems, but I'm not going to worry about it. Oh no, it won't. Okay, so we can just hook this up into the pitch, into the duration, into the amplitude, into the position, and then we've got all of our bases covered in terms of banging out these probability tables. And then when I get to the end of this line is when I'm going to want to hit this delay. So I could just hook this straight up there, but in case this patch is getting altogether too messy already, I'm going to make a new object with a send, and I'm going to use the pound symbol 0 with a dash end ing, end or end ing, I don't know, ing short. So when the line gets to the end, which is going to happen over the duration of the grain, then it's going to send this this #0 argument that I put in that send will allow it to be, you can't just use a send because without something like this, because otherwise they're all going to get this receive. If I make a receive, that'll all get it. Whereas this will be when these various copies of this patch load in the poly tilde, this number here, this #0 number will be changed. It's kind of a useful thing for making multiple copies or abstractions or to be loaded in poly tilde. And I'll make it an R with the same name, just duplicate it and change it to an R. And the other thing I'm going to want to do is so that I can turn this thing on and off, I'm going to gate this value coming here. I'm going to gate that using a gate of all things, so that when it's off, that end value doesn't come on anymore. And it won't hit this delay unless the thing is turned on. One last thing, when we, I hope it's one last thing. So when we turn this thing on, we're going to want to start by hitting that delay. And now we should be able to save this as something. Pretty sure that's all that we needed to do. All right, so save this as, I'll call it granular-poly. Okay. And out here on our main patch, which is now gone disappearing, I can now make a poly tilde. So poly tilde with granular. It needs an R, doesn't it? Granular poly, and it's there. And I guess we'd give it another argument. Just let me change the size of that. So we can give it an argument of, change the size with auto fix width, doesn't work, but all right, so we're give it an argument as to the number of voices. We can have 16. A good thing about this, because it doesn't require any input to make it work, is that you can change this number however you see fit. I'm going to start with 16. Just you can make your whole granular world a lot more dense by making that a larger number. And we're going to stick in here an easy DAC. Okay. Now I suppose we probably want to set some of the values in these tables. Let's make the intergrain time. We can make it like some short, some long, and durations. We can make them all kind of longish. Amplitude. Let's make lots of quiet ones and some loud ones. Okay, some louder ones. Pitch for the start, I'm just going to put one point at 64 there. Was that point at 64? 65. So they're all just going to be at the original pitch, and I can choose whereabouts, the likelihood of where in the buffer it's going to play back from. Turn this thing on, turn the thing on and off, and we can now play around with some of these values to see what. Yeah. Very good. Okay, so now let's look at how you can sort of morph from one setting to another using the pattern storage. So let's make a new object here, pattern storage. Okay, and to get these script named objects into the pattern storage, let's do the easy thing, which is to make something called auto pattern. So auto pattern, when you create the auto pattern, anything that has a scripting name, will show up in the pattern storage automatically, which is very nice, very nice. Okay, and then we can use message store. So I can make a new message, store with a number, $1. We can store it at different addresses in the pattern storage. Use an I for int to store these things. Then I can read back those stored values using a float, so F for float, so that we can interpolate between stored presets. Let's store the one we have here as 1, and let's go and mess with it a little bit. I'll turn it on while I'm messing with it. It's not very interesting. Okay. A little bit of pitch variation. That's a lot of pitch variation. I don't know what to do with the amplitude. Ink grain time, make it much sparser. And durations, let's make them all shorter. Alright, I'm going to store this in position 2, and then if I hit 1, it should recall the first preset we had there. And if I go between between 1 and 2, we can morph between 1 and the next preset. Alright, so that was indeed patch at day 34, and I'll see you in 35. Bye.